This is the first CNC lecture of CAM 810S. The topics: definition of the term CNC, the advantages, applications, and components of a lathe machine, of a CNC lathe. Let us start with the definition of the term CNC. Computer numerical control, CNC, is one in which the functions and motions of a machine tool are controlled by means of a prepared program containing coded alphanumeric data. CNC can control the motions of the workpiece or tool. The cutting parameters such as cutting speed, depth of cut and feed, and miscellaneous functions such as turning spindle on and off, turning coolant on and off, and others. Compared with conventional machining, CNC offers quite a number of advantages. The part to the left could be done on conventional machines, but it would take a lot of time. Whereas the part to the right, however, could hardly be done on conventional machine. Another advantage is high accuracy. Parts are produced with constant and high accuracy. Short machining time is another advantage. After the program has been produced and the machine has been set up, machining time is very short. Whether we produce one or many parts of the same type, the quality remains constant. High flexibility is another advantage. Once programmed, recurrent parts can be produced again and again. Production can proceed according to plan because setup and machining time for parts are well defined. Produced parts can be delivered to the customer right on time. This is an important factor for customer satisfaction. In case of major flexible manufacturing projects, CNC machines can easily be integrated into an FMS. And now some common applications of CNC technology in mechanical parts production. Drilling, turning, milling, surface grinding, cylindrical grinding, sheet punching or nibbling, as it is also called, laser cutting, mainly for metallic parts, water jet cutting for all types of materials, engraving, and last but not least, wire EDM, wire electric discharge machining, which is employed in tool making mainly to produce hardened dies, for instance. Let us now look at the design and the main components of a CNC lathe machine. We start at 6 o'clock below at the base of the machine. It is called machine tool frame. That's the component on which all other components rest. The slant bed, this is the slant bed, is fixed to the machine tool frame. The bed is slanted or inclined so that the chips which are produced when turning can fall into the chip collector from where they are removed by a chip conveyor in this case. We continue at 9 o'clock and go clockwise. This is the main drive, normally an AC servo motor. This machine is equipped with a clamping cylinder for automatic clamping. Then we have the main spindle and a 3-jaw chuck for clamping of the parts. All these components are covered by a metal casing all around these components. At 12 o'clock, we have the tool turret. This is the tool turret, which is fixed to the X slide. The sliding door, this is the sliding door to open, close, is equipped with a window out of safety glass. Then we've got feed motors for X and for the Z slide. We have got a cabinet for electric components. There is a monitor for data display and a control panel for data input and machine manipulation. The tailstock is here, also mounted on the slant bed, so that we can turn long cylindrical parts. We look now a bit closer to the RPM control of the main spindle. We start at 9 o'clock, where we've got a 3-phase servo motor which drives the main spindle. The main spindle is equipped with a brake unit so that the spindle can stop immediately. A taker generator measures the RPM. The value of the RPM is fed into this comparison of reference input and actual value. RPM reference input or the set value. The controller computes a variable, and this variable is then fed into the motor so that the motor turns exactly at the programmed speed, at the programmed RPM. We have got a closed loop control. Concept Turn 250 in our lab is equipped with a 3.7 kilowatt motor with an infinitely variable speed range from 50 to 6,300 RPM. a feed drive. In case of a CNC lathe, the feed drive for the Z and for the X axis is composed of a feed motor, a clutch with overload protection, which transmits power to the spindle, which moves the slide forward and back. The bearing to the left is a fixed bearing, whereas the bearing to the right is a floating bearing, so that the spindle can dilate in case of heating without any problem. The floating bearing is making small movements in the 1,000 and 100 millimeter range. The spindle is a very special one. It's called a ball screw spindle. And the nut is also a special one, which is called pre-loaded recirculating ball nut. You will study more about these important CNC machine components later on. Feed drives must have a high amount of feed power, a wide speed range from very slow to very fast. There must be a high acceleration rate. The slide must be positioned very rapidly. There must be a high repeatability of the targeted positions, and targeted positions must be maintained very rigidly. This is the end of the first CNC lecture of CAM 810S. Please do your exercises. Thank you.